Hello, in this video I will just be shortly going over some information regarding bitwise operations in C++. The way we perform bitwise operations actually derives from the C programming language, which is C++'s predecessor, and is commonly implemented in other languages as well, which stem from the C language. Learning the various bitwise operations, as well as being able to read and interpret what's going on, can be pretty difficult at times, especially if there are a multitude of operations happening at once, which is why I'll be giving some examples later in the video. To start off, I'll be including the bitset library so we can more easily be able to see the binary representation of data. And so now I'm going to create an unsigned 8-bit integer just so we have a small data type, and so we don't have to worry about just sort of a lot more bits that are being operated on. So I'm going to go ahead and do that right now. Data. Okay. And so this data type may seem a bit weird. All it's doing is creating an integer that's unsigned and will only have 8 bits. Normally, a regular integer is going to have 32 bits because it's 4 bytes in size, but we won't be working with that many bits in this video, so I'm just going to create a smaller one that has only 8 bits, just so it's a little bit easier to read. And so now I'll just be printing the binary representation of data just so we can actually see what that's going to look like in our console. Okay, save this and run that. And as you can see, we get a 8-bit binary value of data. And I haven't assigned a value to data, so it's going to sometimes either be a 0 or it's going to just be a random value according to what's in our memory. So remember, in C++, values are not automatically assigned to variables, so you want to make sure that your variables are already assigned a value when you're working on them. So I'm going to go ahead and give data a value of, just for example, 5, just so that we have a consistent data or consistent sort of set of bits that we're working with, rather than a constantly changing amount. And as you can see, after assigning it the value of 5, we will have a consistent bit set to work with. So let's go ahead and look at bitwise operators. One thing to keep in mind is that it's useful to separate operations with parentheses. This makes it a bit easier to read as it exemplifies what's happening first before something else. Secondly, with bitwise operations, unlike mathematical operations, not everything is read from left to right. Some operations take precedence before others, and I'll be giving an example of this later. And so the first operation we'll be looking at is bitwise shifting. Bitwise shifting is a way of shifting bits in your variables towards the left or towards the right. And so let's go ahead and see what that's going to look like. I'm going to start off by shifting all the bits and data towards the left twice. And so let's go ahead and see what that's going to look like. So as you can see right here, the bits and data have now been shifted left in this example. The bit that was starting out right here that was turned on has been shifted once, twice, and so now it's ended up right here. And the bit number 1 that was shifted right here, shifted left once, and then shifted left again. And so let's go ahead and see what will happen when we actually shift right. And I'm going to show you the original bits of data, just so that we can actually see what it started out as. Alright, and as you can see right here, this was the original bit set of data, and then now we only have a single bit remaining. And so the reason why this has happened is because, if you recall, I said that data will have only 8 bits. And so now when we have tried to shift these bits over towards the right, this bit that was starting out right here was able to shift towards the right, and it is this bit now. So this bit right here has now become this bit because it is shifted over once and twice. However, the last bit that was right here did not have anywhere else to go. It was the least significant bit in the data bit set. It had nowhere else to go, and so the bit in this position was overwritten. It's important to note that the least significant bit, whenever you're shifting whenever you're shifting right, will always be overwritten. You will um, always have to sort of keep in mind that the least significant bit when you're shifting right can be overwritten. So it may either be a 1 or a 0. Um, and just in general, when you're shifting bits, always keep in mind that in C++, there is no type promotion when it comes to sort of assigning bit shifting values. So what that means is that if you were to shift uh, the bits more than you have that are able to accommodate that shift, then all your bits will be overwritten. And I will actually show you what that looks like right now. So I'm going to go ahead and shift data's bits towards the left 8 times. So let's see what that looks like. And as you can see here, there are no bits turned on. It is essentially just 0. And the reason why is because, again, we have only 8 bits. All of these bits are just what data will have. It has no extra bits for these 2 bits right here to sort of be shifted into. What ended up happening is it was shifted left, it was shifted left again, and it was shifted left 8 times. And so essentially it had no bits to shift into. And so again, the zeros sort of took over the positions where the bits were, because again, there were no bits remaining for them to shift into. And so it's just, again, important to remember that when you're shifting bits, you want to keep in mind the size of your data type, because the size of your data type will determine whether or not you have enough bits to accommodate for your shift. And so if you are shifting more times than your data type has bits, then you will run into issues where you'll be overwriting the bits in your bit set. I'd also like to note that with bitwise shifting, as well as other bitwise operations in general, they do not actually impact the value that goes into your variables. You have to actually assign the operation to the variable. Otherwise, the operations will just be temporary. So in this case, data's shift will not actually impact data's value because it's only temporarily being shifted. And to exemplify this, we can print the bit set of data again. So I'll just go ahead and show you what that looks like. And as you can see, data's bit set has not changed. It was only temporarily changed when we were shifting it in the second cout statement. And so if we wanted to actually change the value of data to what we wanted to shift it by, we can do that by adding the assignment operator at the end of it. And then that will actually change the value of data. And we can see that right here. And we even get an error that is warning us that we are shifting with an amount that is greater than or equal to the amount of bits in our variable. So the compiler is able to see that, hey, you're probably doing something wrong, in which, again, we are, because we're shifting more times or as much as the amount of bits in our variable, and so we are essentially overriding the entire bit set, or rather the entire value of data. So again, this is just something to keep in mind with bitwise operations. The operations are only temporary unless you assigned them.